See my screen? Yeah. Yes. You're presenting. Okay. So if I go in here, so we did basic switch and basic switch configuration, how to configure a switch. We did a bit of protocols, the OSI model, layer 1, layer 2, layer 3. All these, you should know them. Job interview, we can ask. We studied the physical layer. We did check the numbers, decimal, hexadecimal, binary, how to do the conversion. We checked layer 2 data link, layer 3, the network layer, the ARP, how to do basic router configurations. You see, when you do all these chapters, you have a good background in IT. You can do a lot of things in any IT in this world. That's why people will respect really, really, really with CCNA. I've been through that. I know it. I know about it. We did check. Oh, sorry?
I said it's not a joke.
Yeah. It's not, people think it's something. No, it's difficult. It's not difficult, but it's a lot, and you need to be serious to win. And you guys, you will win. You will win. When you finish, you put on your CV. When you start working, getting good salary, you forget all the pains and things so everyone went through them. I've been through there, I know. Me, I used to wake up at 3 a.m. in the morning. I study 3 hours, 6 until 6 a.m. I bath and I go to work. You see, for 1 year, including Saturdays and Sundays. So it's up to you to organize yourself and do a lot of packet tracer. But I'll help you know what is. You just need to study. So now in the OSI, we have something called the transport layer and application layer. Tomorrow we'll do network security. So let me check the timetable here. So today we'll try to do a bit. Tuesday we do a bit. Wednesday we finish everything, the remaining ones. Then we are done with the theory. When we are done with the theory, now we're going to do the labs to start preparing for your exam. So I'll try to choose some packet tracer to prepare you for your exam. If you know how to do it, it's almost exactly what you can face for your exams. So if I go to our YouTube channel and go to videos, especially lab, you see 10.4.4. It's similar to the exam you're going to get, but I'll try to guide you, to prepare you. And can you hear the sound or not? Yeah, so you see something like that. So we're going to do many of them. We're going to do many of them, and just to get ready. Okay, so today we're going to do something very simple. Very, very, very simple, called ICMP. So ICMP, it's a layer 3 protocol. So the OSI, we have level 1, physical layer, layer 2, data link, layer 3, network, where we deal with IP addresses and also the ICMP. The ICMP, we have two protocols inside. It's just to test connectivity. For example, if I want to check if I can communicate with Esther or Denise or Sangani or Christina or Mama Emi, so there is a tool called ping. I'm going to show you. There's a tool called ping to test the connectivity. So we have the ping and we have a trace route. Trace route is used for troubleshooting. For example, you want to go to, let's say, to China. So you must take a plane from, for example, Cape Town. You land in Johannesburg. From Johannesburg, you go to Addis Ababa. In Addis Ababa, you take another plane to go. So always path where you take, where you land, when you take, where you land, and the trace route will trace the packet. What are the path the packet is following, is using to reach the destination? So that if you say, Mr. Sangani didn't reach the destination, he's lost. But if he's lost, where can we find him? We'll check. Did he take his plane from Cape Town? Yes. And where did he land? He landed in Johannesburg. So from Johannesburg, did he take any plane? Did he take another plane? No. Why? Sangani lost his passport in Johannesburg. Then we can go to Johannesburg to find him. So when we want to send a packet to somewhere, if it doesn't reach destination, we can trace where the issue is and we fix so that the packet can continue go. You see, that's about ping and trace route. So ping and trace routes are two tools to test network connectivity. And they belong to ICMP. They belong to the ICMP. Okay, this one is not too much important, but we're going to. So if there is an error, you have some code. Error 0, it means network unreachable. Code 1, code 2, code 3. I'll show you some example a bit later. So let's say I want to ping cisco.com. Let me use something here. I type CMD for command prompt. Press enter. So this same chapter, you can find it in our YouTube also. I did, if we go here, it's on chapter 10, huh? No, chapter 13. If you go to a video, I'm going to record this one, so you have two videos. So you can also watch many times. Okay. So if you go to CCNA1 Extra, chapter 13 and 14, it's the same thing. So if I use here, and let's say I want to communicate with cisco.com, and I want to know if I can communicate with it, I type ping, for example, cisco.com. Like, so the ping is like, I take my cell phone and I try to ping a Cisco cell phone number. If it rings, it means, we can communicate. I press enter. So it means from my PC, I did send 4 packets. My 4 packets came back to me. It means I have 0% loss. So I send 4 packets to cisco.com. Cisco.com reply to me. It means we can communicate. If I send with 4 packets and I didn't receive anything, it will be lost. You see, it means maybe Cisco.com is down. I cannot communicate with you. So this is the reply. I ping with Cisco.com. This is the IP address of Cisco.com. And if you see TTL, it means time to leave. If a packet doesn't reach destination, it will decrease. So if, for example, TTL was 5, anytime it reaches a router, you do -1, -1, -1. So if it reaches 0, it will destroy itself. So ping is a tool to test connectivity. For example, I can also ping what again? It's a Pretoria news. I'm not sure if this guy is still there. Pretoria.co.za, are they still? Okay, we are still there. It means I can open a web page of Pretoria news. If I take this one and I open a web page, the web page will open. Did this one, Pretoria.co.za, I press enter. Okay. So these guys, they merge in IOL. They have been purchased by IOL. It's here. Yeah, so this is a simple tool to test connectivity. Now we have the second one is called traceroute. Traceroute. If you watch American movies, we see trace route. But for us, we see traceroute. So you can read this one quickly and we continue. Okay, so this one is for ping. Now we're going to check the trace. There is something called 127.0.0.1, and this one is you're pinging yourself to make sure that your network interface card is working. We call it the loop back address. Loop back address. Sometimes we ask for a job interview. A loop back address is an address we ping to check if my network interface card is working to communicate with other people. Come here, ping 127.0.0.1. Means my network interface card is good. I can communicate with other people now. The other one is called traceroute. Is to trace the route, to trace the path. If you're using a Cisco router, it's traceroute. If you're using Microsoft Windows, it's trace RT, RT for router. So you can also read this one, and I'm going to explain this one for you. Okay, so traceroute is a tool to check the path, all the stations, so like the train stations, all the stations the train will stop until it reaches destination. So you can also use it. You come here. So instead of real news, I type trace, because here is the Windows. I'm not using a Cisco device. I type trace RT and I press enter. So you see the packet is leaving my home router, my Wi-Fi from home. It's going there first. Then it's going to go to my ISP. My ISP will go to, you see it's going somewhere. Yeah, sometimes it takes time until it reaches destination. So that's all for also trace routes. We'll do some labs for that. We're going to check how we use it. So it's very simple. You tap, if you're on R1, trace route and the IP address of the destination. Oh, who is that? Okay, so that's all for ping and trace routes. If I want to reach a destination, you tap trace route and the packet will display all the path, all the stations you're going to reach, to go through until it reaches destination. So that's all for phase 2. So we use it for troubleshootings. We're going to do also a lab on that a bit later. It's a very short chapter. Do you have a video on that? No. So the purpose of ICMP message, ping or traceroute, is to provide feedback about issues related to the processing of IP packet. We'll do some labs on that, so no worries for that. So this one is a very short chapter. Let's check. Then we'll do the transport layer, also short, and application layer. We are very short. Okay, we'll check one of them. Let's do only the transport layer. Then tomorrow, and we can finish with. So transport layer is a layer 4. If you go to our OSI model, the secret to be successful with Cisco is you plan well your study time. You tell yourself every day, 2 hours per day, 1 hour for the quiz, or maybe 2 hours to read your chapters and do your quiz, 1 hour for packet tracer. Every day. If you do that, listen. This one is a CCNA 3. No, it's not this one. So we go to, so we did the physical layer. What is it, this guy? We did all these. When you finish, your title is network engineer. The only thing now is to practice a lot, to do some maybe internship, and you can get a job. Me too, when I left my country, I came, it's the same thing I did. I was practicing, and one day someone was interested, and I started with Cisco themselves. So nothing is impossible, nothing. What is the OSI? Okay, anyway, so let's start then. So which one is layer 4? The transport layer. The transport layer, I want to show you something. The OSI model first. We have a lot of info, but I'll make it very short for you. Mm. No, I need to find that. I think here. F OSI. Yeah, transport layer. So we know the physical layer. We deal with the bit, anything relating to media and cabling. So this one you know. Layer 2, the data link. We deal with frame, MAC address, and the device. Managing this level is the switch. We deal with network layer, anything related to IP address, ping, trace route, and it's the router who will deal with. Now the transport layer will make sure to move the packet from A to B. So inside we have two protocols that will help us, or let's say two buses. Let's say you want to go to Johannesburg, you can take two planes. You can take South African Airlines, or you can take maybe Mango Airlines. So they'll transport you from Cape Town to Johannesburg. Now, what is the difference between South African Airlines and Mango Airlines? It's what we're going to check. So the transport layer is responsible for end-to-end connection, and we have a choice between TCP and UDP. TCP is more secured, UDP is less secured. So there are a lot of readings here. Yeah, this one. So at the transport layer, we'll see we have some applications that will use TCP, like FTP. If you want to upload some files or download some files, FTP. If you want to view some web, it's HTTP. If you want to read emails, SMTP. All these protocols are responsible for that. And they use TCP for the transport and to move stuff. But UDP, it's something very light, not too much serious, like DNS or TFTP. But if something is very serious, like emails, managing emails, web, uploading, downloading stuff, it's TCP. So you can have a look on this, and we continue. Okay, so now in this chapter, we're going to explain more TCP and UDP. So TCP is going to establish secure connection. So if you want, you can copy my screen and you paste on the Microsoft Word document. You copy it so that you can, because which one is very simplified compared to NetAcad, where you have too much info. So TCP will establish a session, ensure that the packets are delivered. If something is lost, it can resend again. See. But if you use UDP and some protocols, some applications using TCP, we have HTTP, FTP, SMMT, and SSH. We'll have time to study them in CCNA2, the second part of CCNA. So if you want to use the web, this is the protocol of the application that will manage the web. If you want to download, upload, it's FTP. If you want to manage emails, it's SMTP. If you want secure remote connection, it's SSH. The three-way handshake, before I start talking to someone, that person must agree, then we can start talking. We call it the three-way handshake. We're going to check that also. You see, if PCA want to communicate with PCB, we have three-way handshake. PCA will say, okay, are you there? Say, yes, I'm there. And PCA will say, okay, now we can talk. Let's start communicating. So this one is TCP. It's more secured. The UDP, it's different. It's like the post office, and you drop your envelope and you go home. You won't know if it's reaching the destination or not. That's the UDP. And we say it's connectionless. I don't need someone to pick up his phone before I start talking. I dial your number, I start talking. You are there, you're not there. That's none of my problems. So UDP is less secure, is connectionless. I don't need a connection before I communicate. So normally, these are some applications using UDP, DHCP to automatically assign IP addresses to end devices, DNS to change IP address to a name or a name to an IP address, simple network management protocol, TFTP, voice, and video conferencing. We are going to use UDP. So you don't need to memorize all these things. It's just to have an idea, that's all. So we don't memorize here. So these are some example of things you can do. You can check this. If you're using voice over IP in your company or domain name resolution, use EDP. We are fast. We don't need a lot of issues. But TCP, if you want big issue like the web, the emails, you use with TCP. It's not you you're going to use, but this is how networks has been designed. In the background, we use that. So have a look and we continue. Okay, so normally if you know the definition of a transport layer, what transport layer will do, what is the difference between TCP, UDP, what are some applications that use UDP and TCP, that's all. Anything else is, now, each application here, we're going to use, so when you have your laptop, inside, it's like we have parking lots. If you want to use emails, they have their way. If you want to use DHCP, we have their way. So each parking lot is called a port number. So a port number will identify which application PC or the laptop we want to use. So TCP and UDP, transport layer, use port number to manage multiple simultaneous conversation. It can be emails, it can be the web, it can be a phone call. So all of them, you won't mess up. They have their own line. So if you want to use, for example, Telnet, you're going to use line 23. It's inside your network interface card. If you want to use, let's say, so anything, emails, simple mail transfer, we use port or lane 25. So this one, it's compulsory for IT engineers to know the port numbers. So normally that's all for this chapter. So in this chapter, what you should know the definition of, what is this guy again? OSI. Yeah. So we know the physical layer, we deal with media and cabling. We know the data link layer, it's mostly frame and MAC address. If we switch, we deal with that. Network layer, we deal with IP addressing, IPv6, IPv4. The PDU is called a packet, it's a router. And now we have a transport layer. Make sure that end-to-end connectivity, and we have two protocols, TCP and UDP. So if you know the definition of transport layer, the definition of TCP and UDP, and port number, that's all for this chapter. Anything else in NetAcad is extra stuff. So let's stop here for now. And from time to time, when we'll do the labs with packet tracer, we'll come back here and to do some revisions. So 2 minutes, take your time to read here. It's important. Okay, guys. So what you should know, if you read your NetAcad, port numbers, the definition of transport layer, the difference between TCP and UDP, it's explained here, and some applications using TCP, some application using UDP. And if you know your port numbers, that's all. At a later stage, we'll try to do a bit of packet tracer on this. So please study. If you have any questions, post in the group or contact me. No problem. I will help you. Okay, guys, any questions? If no questions, then we can end the session for today. But before that, let me check. The register for Scalabrini. I'm going to grab here into Sangani. Allez. Oh, sorry. Z, Control U, Control V. Then, who else is there? Sangani. Oh, sorry. So it only shows. Okay, thank you very much, guys. So if you have any questions, please let me know. Don't forget to do your chapter exams, and yeah, we'll finish with theory. After that, we'll do a lot of practicals with packet tracer, and I'll try to help everyone. If one day you want help, you see, Mr. Max, let me know. One day you can take maybe 30 minutes, and I log on your PC and I help you for anything. If you need help. So we are almost done for CCNA1. We'll do the exams week 3 of, let me say my Gmail, send to Enoch. I was Calabrini. Yeah, Max and me too. Thank you very much, guys. Have a good evening. And we'll meet again tomorrow, very short also. Thank you, guys. Thank you.